We're back with the stream. Sorry about technical issues. It's now the last hour of the competition. The leaderboard is frozen. We will not see officially verdicts. We will only see question marks. We don't know if somebody solved the problem or not. The last accepted solution was D by, I think, a tunnel. I'm not sure now. We have two teams with 10 problems. As we expected, EP Chopper with smaller penalty time got to the first place. The total penalty time is the sum of your submissions for accepted problems plus 20-minute penalty for each incorrect submission. If we look at problem G, submitted a lot of times by UPC1, we see that if they didn't have those 4 incorrect attempts, their penalty would be better by 80 minutes. So 876, and that would put them above EP Chopper. It likely will not hurt them like this here, because we still expect some problems solved by both maybe EP Chopper and UPC1. But it always hurts to lose by penalty time, thinking that you could have avoided it by maybe testing your solution a little bit more. In total, though, of course, the speed matters. If you solve problems quickly, even if you have some incorrect submissions, you're okay. Let's see the full leaderboard, not only the first page. And on the left, it's good to follow the submissions now with H submitted by, on 4th place, EP Rouge. A lot of teams have exactly 4 problems, B, C, F, and I. Those were really like approachable, solvable problems. Then a bunch of teams with 3. Everybody that's tried something, they have at least 2 problems, B and I. Those 2 last teams, likely they are not here. And now going through the screens. Screens of top 10 people. Top 10 teams. There is submission for D by taking Rubber Duck from 8th place. But even with that, they will have 7 problems, not enough to threaten the very top. EP Chopper working on D. UPC1 again in Vim, harder to figure out. But this was problem H, the one about random numbers. Yes, that one is H. ETH Zürich, solving L. After we are done here with screens of top teams, we will take a look at the leaderboard of the mirror contest. There is one team, Coach Better Than AdCoder, and they already solved all the problems. But there is Hoshiron on the 2nd place with much smaller penalty time and 11 problems, so likely they will get the win. Unimi, Statale Blue, computing factorials, so likely solving problem about counting trees. I think it is J. Here 7 different characters. So problem D. Technion rubber duck, Scuola Normale Superiore, implementing G, just starting. And whom do we have on the 10th place? University of Bologna, Uniboys. The team that solved problem A very quickly in 43 minutes. This is the leaderboard, currently leaderboard for the mirror contest, the one where, by the way, you can see statements of all the problems. Coach of Better Than Coder with 12 problems, the whole problem set solved after 232 minutes, so 8 minutes before the leaderboard being frozen. But Horishun has right now time penalty 866. Even if they submit E in the last minute, so 300 after the start, they will be at 1166. They can, it wouldn't hurt them to have like 15 more incorrect submissions, maybe 10. If they solve E, they will win. Are there some other teams who can threaten the first place? In the third place, if they quickly solve 2 problems, each with 250 minutes now penalty, it's 500 in total, so they will not win. I think the same below, maybe 5th place. 4 times 250 is 1000, so proved by the wrong answer tour, they will be at 1567, even if they right now submit everything. Oh, and they have some incorrect submissions. So it's only fight between Coach of Better Than Coder and Hoshirun. And my money is on Hoshirun here, assuming they can solve problem E. Let's talk maybe about problem E for a moment. I incorrectly said at one point that it's a game of life. Not really. In this one, you can press a pixel and it will flip the state of this pixel and all adjacent ones. We'll see that in a moment. For problem E, pixels, what do we have? Let's say we start with some empty grid. Then we can press a cell, a pixel. It will change the state of this cell and also all adjacent ones. Now what happens if I press this one? Right here, it will change the state of all adjacent ones, so those two will be cancelled and those will be on. You can think about zeros and ones, and if you click something, it changes the state of all the adjacent cells as well. In particular, you can click this one, and then those will be flipped as well. The limit for this grid is k times, maybe not k, height times width is up to 100,000. And we need to check if it is possible to move from one state to the other. And it's quite obvious what it means. So can we move from this state to this one, for example? Actually, it isn't that important what is exactly initial and final state. It is only important which cells we need to flip. So this is equivalent to answering a question about moving from this grid, let's say just empty grid, to this one, where this cell changes, this one, only the bottom right cell doesn't change. So I can as well answer this question. Can I get this one? And here the answer is true. I can do that by just using this one. And then indeed in the initial thing, the state of those three cells will change, it will flip, and we'll get cell that the grid that we want. Yeah. You can think about some greedy approaches here, but this is not a way to go. Instead, we should do it smarter. What I mean is you can go maybe from top left corner and try to say if you should use this cell or not. Basically, for every cell, at the end, it matters if you use it an odd number of times. If you use some cell twice, you could as well not use it. So the solution, the way to reach some new grid is just a set of cells to click. And maybe there are multiple possible solutions, by the way, then print any of them. You can output any of them, because if the answer is yes, you need to say which cells to click. And how to approach such problems? Where there is a thing called Gauss elimination, and we will try to use this. Usually Gauss's elimination is there to solve a system of equations. It maybe this problem doesn't look like a system of equation, but it kind of is, because the fact that some cell, like this one, needs to change, it means that some cells must be clicked odd number of times. If you say that every cell is a variable, say x1 is this one, then x2, x3, x4, x5, x6, and so on. So this is x12. Then the fact that this top right cell, it needs to flip from one state to the other, it means that x5 XOR x6 x12, it must be 1. And xi means I want to use cell I odd number of times. So it's either this or maybe 0. And this is a system of equations we need to solve. And while bitwise XOR isn't something Gauss can handle, you can think about it as system of equations modulo 2. And we can say that modulo 2, we require x5 plus x6 plus x12 to be 1. Then the same for every cell. If let's say you have a cell A surrounded by cells BCD, XB, XC, XD, and XE, if cell A in the middle of them, it should not change its state, we say this. And here we have a long system of equations. And the difficulty of this problem is to create this, and thanks to the regular structure, we need to solve this efficiently, because the number of variables is height times width, and normally the system of equation with that big size you solve in cubic time. Just if you have a grid representing some system of equations, then the time will be what am I saying? The quadratic one, sorry. But here this thing is quite sparse, not dense. So the official solution says, use Gaussian elimination starting from the controllers associated with top left pixels. Yeah, and like fix them one by one. The final time complexity will be kind of square root. We want to get this complexity O of h times w times minimum of the two. And once you get this, you're good. You can notice that this will be maximum possible value when h and w are equal to each other, because this is always 10 to 5, so the right terms should be maximized. So this is not greater than O of this. Let's say that this is limit for n. Then the complexity is n to 1.5, or n times square root of n. That was problem E, pixels. What do you have in the standings? ETH Zürich on the 4th place submitted 2 problems, G and H. They might be right now on the 3rd place. We can see optimistic and pessimistic leaderboard. So optimistic if everything passes for every team, this is what we have right now. This assumes that that extra submission, for which we don't know the verdict, it passed. Then here we see ETH Zürich being on the 3rd place, but as well, all those yellow submissions, they might be incorrect. We don't know that. So let's get back to the standard view. And while EP Chopper and UPC1 likely they fight for the 1st place, ETH Zürich, if they solved both G and H now, they are looking strong. One more problem and they might win. They just, well, they need to solve that one extra problem and hope that EP and UPC1, they do not. Nobody is submitting E. Well, given this leaderboard, first 2 teams should try to solve E, but only after D and H, and everyone else should prefer L over E. Now we will scroll through the leaderboard. Let me check that.
Basically nothing changed.
Nothing surprising in the middle of the leaderboard. Still a lot of teams with 5, 4, 3 problems. Everybody with at least 2. And this is time where it would be very nice to see screens of some teams in the top. So let's do that. what do we have? We will first see what EP Chopper and UPC1, what they work on. We expect D and H, maybe some of them already are solving E. Then we should see Gaussian elimination being implemented, modulo 2. Then we don't know what MEF is working on, and EP Rouge is also a very interesting thing to see how. EP Chopper has D. Actually, they have D.cpp, DD or D1.cpp, and DDD.
Yes, they make 3 re-implementation from scratch each time.
Okay, so they don't know maybe what they did wrong. Here we see E. What is this exactly? Something with masks. But is there Gauss elimination there? MEF without 3 problems right now. Now debugging L, seeing what happens for the second sample test. They don't have correct answer here. EP Rouge. They do work on L, I think. Yes, it's L.cpp. And this might mean that H and G were accepted. MEF submitted L. Let's switch to that. Pending. If we want bigger suspense at the end, we should right now not look at this. So if you want that, you can turn off your screen and speakers for a moment. But will this pass? If yes, then they easily join a fight for the first place. And this is indeed accepted. So we know that MEF is tied for the first place. The ties are resolved by time penalty with the other 2 teams. It's for sure a very nice feeling. A lot of teams might already have switched to just solving one problem. We see a lot of discussion. EP Chopper here on the foreground, just working on one thing. Let's see what they will. Yes, maybe they created DDDD. Did they? Let's see. No, it's still only triple D. If something doesn't work several times, well, it's a strange thing to decide to write it from scratch because they didn't submit. I think it more often happens when you submit a solution, it doesn't work, you have no idea why, then maybe you made some strange mistake, and I would guess that then more often people decide to rewrite a solution. Here they had two versions, they didn't submit that, so maybe at the beginning they decided, oh, it should be done completely different way, or it didn't work for the sample test, they couldn't figure out why, and they started from scratch. We will now gladly accept proposals in the comments for teams that we should open, for like screens you want to see. here's on the 5th place. UNS ULM1 code for G. Does it mean it's accepted? Maybe. They are working on L. We also see D being open, but they did get that accepted. So it's either that G was already solved, or maybe they worked on that in Vim, for example. Bunch of DFSs in D, something with XOR. We are likely looking at the correct code for L, like correct idea, but still from that there is a long way to getting the accepted verdict. Number of 0, yeah, number should be used for sure. Exactly 30 minutes left. Please increase the volume. Well, if there are multiple people saying it is too low, then we will increase that. On the 6th place, ethanol submitted G. After ENS, we will get to that screen. And G was accepted by ethanol. They move up in the leaderboard. So we know they have 9 problems, but other teams do not know that. Let's remember that for everybody it's a fight to get into around top 4. It isn't official what is exactly the number of teams who will be qualified to the World Finals. But it is around 4 or 5, and there is a rule that only at most one team from the same university can advance. So if there is, let's say that 2 teams from the same university, they get 1st and 2nd place, the 2nd place will not advance, and instead a team from 5th or 6th place will be taken. The algorithm is to go from the top of the leaderboard, and if nobody from the same university was accepted already, and there are still spots in the finals, then this team gets accepted. On 8th place, Technion Rubber DAG is now submitting L. And what will we see? It's pending. And also we saw that L is, the previous one, D is time limit exceeded. L still pending. Now the volume should be quite a bit higher, since people suggested so. Yeah, and here we see L is correct, so now they move a bit up. They will now have 7 problems. Doesn't look so promising looking at the current leaderboard that they see. They will actually not gain even a single place, but there are for sure other teams that will have 6 or 7 problems. We are now seeing standings from the moment leaderboard was frozen, 60 minutes before the end. Even if you think extra problem did not help, it likely will help. Plus, they should fight to get one more problem done, obviously. So for hard problems, there will be some spoilers for a bunch of problems now. If we look at topics of hard problems now, D, solved by around here, maybe 8 teams. D is about creating some big structure, graph-like structure, and not to get exponential complexity, we need to use a hash to say that something together with something has a new hash. Then problem E is the one about pixels and adjacent cells. You need to use Gaussian elimination. Next we have problem G about some string and getting lexicographically smallest version. We need to efficiently, in some way efficiently, move small letters to the beginning of a string. H we know already, it was pseudo-random number generator. And was about figuring out that cycle is very short. Then we have J, which is kind of combinatorics. And finally, L is game theory. So for today, this is topics good to know in order to solve hard problems. Can you please increase the volume just by a little bit? Here you go. We had a new submission by EP Rouge. Let's for now not look what they do. Let's have some tension. Screen of ETH Zürich, please.
It's in such places. Column 6 will definitely the same to the best.
Which one is it?
They're both from the Universitat.
The ETH Zürich was suggested, so because there are 2 such teams, meth and methanol, let's see them both. Meth is working on H, and they submitted L some time ago. We don't know the verdict. They had 9 problems. For now, this H does not look good. There are no pre-computed values, but maybe they are working on that. And ethanol working on 8th place, working on H. Do we see a bunch of zeros printed in the terminal. They try to see some pattern, maybe. What does happen here? They print S modulo 2 in a loop. It's quite surprising that starting from some number you get only even numbers. But this is not enough of an observation to solve the full problem. Surprisingly, this problem is not about some, well, this is about some observation that the cycle is short, but there just isn't much more insight. You should try to simulate whatever is said and in some memory efficient way realize that it is fast enough if you add pre-processing. EP Chopper. Working on that H problem. They already accepted H, and now we see here statement for H. UPC1 solving E. They have three-dimensional vector of Boolean values, vector of vectors of bit sets. That's surprising. They should work, I think, only with two-dimensional matrix. I saw some ceiling in the code. That's a bad sign. You better you do everything with integers. There is an easy way to compute ceiling of division of two numbers. If you divide a by b, you can say a plus b minus 1 divided by b. And this will do the job for you. Here, still G is wrong answer, L is correct. Like 4 minutes ago by ENS Ulm 1. Ethanol team again, solving H.
There's still no any subnets for E.
I wonder what is the probability that there will be some submit for E. We saw one team in the top working on E. So if they are fast enough, they will submit. Here S and S from 9th place working on A. A was a problem about Dijkstra and two types of distances, minimizing CO2, given some time to get between two vertices. University of Bologna, Uniboys, a team who solved A very fast, working on D. Did we have a submission from ETH Chopper for D? We'll see in a moment what was that. EP Chopper is a team you're now seeing on the camera. They still work on ddd.cpp, and we can guess from that that it is not accepted. They need to work some more, maybe rename the file. And while this is the frozen leaderboard, the optimistic version is here. This is if everything gets accepted. In particular, ENS, now we see they have 11 problems submitted. Likely not everything accepted. It will be interesting. In the normal version, EP Chopper has some penalty time advantage. So right now, if they indeed solve D, they will win. But we saw that they didn't solve that yet. They still work on ddd.cpp. So it's an open fight. From the fifth place, ENS fighting for those 11 problems. Even without E, still maybe fighting for a win. But if EP Chopper accepts D, then nobody will beat them without E. Well, without the whole problem set, and it doesn't look like anybody is trying to get the whole problem set. EP Chopper is fighting to secure their first place. We will gladly do more requests from the comments about screens to show. Some interesting solutions behind all that.
That's ddd.cp.
I will get this.
You may find the bug if you want to.
If you want to try to debug their code, here's submission by EP Chopper for problem D. Moving doesn't seem to work. Yeah, but for hard problems, it is very tricky to just look at some code and say, oh, here's a mistake. In a few months, if you tune in for the World Finals stream, there is always a team of people analyzing codes and finding mistakes. Those are cool analytical things to do, to see, where you sometimes know, oh, this character needs to be changed, or here the array is slightly too small. And then you just hope that team you are cheering for will find that mistake. Screen of UPC1, please. Okay, we'll do that in a moment. This is not that ugly code, by the way. Well, all the variable names are one letter. We have fail. This is something. Evaluate of ID. Just your standard code you would expect in a contest. So let's take a look at UPC1. Still working on E. But if they got it correct for the sample test, it is very, very promising, because their solution is at least reasonable. I'm going to take a look at the output. If it is the same as the sample output from the statement, not the same can still be okay. Yes, it looks so. And we have a submit. Is false lowercase or that font is weird? I don't know. I really don't know. And UPC1 submitting E.
I can show them.
Some code?
Because they also see at the pointer.
Okay. So this is the team, and we can look at the reaction. Not so much happiness so far. Still pending. And we saw a wrong answer for a moment. Something is wrong. Yeah, it's very good to test like edge cases. We see here some, well, I would say professional competitive programming. This is what you do in the last 10 minutes if something doesn't work. It's good that all three members
ask us to stop showing the screens.
Okay, that's a good idea. Yes, we will from this moment stop showing screens, especially by people in the very top, and just look at the standings. So this is frozen leaderboard. We know some of these observations, some of this information about question marks. This is the optimistic version if everything is accepted. If every question mark is changed into accepted. In particular, UPC1 in that case would have the first accepted solution for E. Samarth asks, will there also be revealing of actual verdicts during final ceremony? Yes, I think we will have a usual visualization where you go through teams from the very bottom and you show their verdicts one by one. You will see a lot of teams jumping to the top, jumping slightly higher, and so on, and eventually revealing the situation in the very top. Strong reactions from UPC1. In some regionals it can be different, but I think ICPC provides some software to, for example, simulate the leaderboard. But there can be different issues with that. I remember from one Polish competition that things did not work correctly with Polish characters, with special characters, and we had to fix that in some way. Or by hand, maybe even modify every name from special character to the most similar standard one. Here, EP Chopper on the right. The elephant drawing is problem E, by the way. Five minutes left. In some competitions or exams, it isn't allowed to leave for the last 15 minutes. In particular, I remember such a rule from Math Olympiad, because there is a lot of talking anyway in the last minutes. It's louder, and you don't want to disturb your competitors. Well, maybe you want to, but you shouldn't. And it is possible to solve something in last seconds. That's perfectly possible. Especially if somebody has already code, they try to fix as many mistakes as they can, and then, well, when do you submit? If you want to submit 30 seconds before the end, your solution will not be judged anyway because of a big queue. So as well, you could wait for the last 10 seconds. Just fix as much as you can. Here we see bleeding nose not stopping some team from fighting. We will see more and more submission, but also for sure most of them are not correct. A lot for problem J, some for problem A. And this is time when judging system is put to a test. The situation will only get worse. 3 minutes to the end. ENS submitting G, Uniboys submitting G. UPC1 on the camera.
And the change is a guy on the notebook.
Okay, so somebody else is now sitting in front of a computer. Uniboys resubmitting G a lot of times. Two minutes, 20 seconds. ENS G. Around 2 minutes left. Sometimes it's best at the very end to just make random changes. If you weren't sure if you should put somewhere smaller or smaller than, true or false, just try all the options. Are there 4 places where you don't know what to use? Try all 2 to the 4 options. Wrong submissions do not hurt, because it's better to solve a problem with 20 wrong submissions than not to solve at all. It can only help you get higher in the leaderboard. How long after the contest the ceremony will start? Let me check that quickly.
It's 4:45.
Okay, so in couple. have some food. So
In 2 hours.
2 hours.
So it's 3:45.
The schedule now will be hour and a half for food, half an hour of problem analysis, and then 2 hours after the contest ends, there will be award ceremony and the closing ceremony. 30 seconds left. EP Rouge submitting G, Uniboy submitting G. A lot of free submits there. Likely if you see like 10 submissions for something, it doesn't mean well for that team. More often a single submission for something, around half a minute before the end, will get accepted. Last 10 seconds. EP Rouge, Ethanol, Technion Rubber Duck. A lot of colors. K, G, A, L, and 5 hours. That's it. No last, I think no last minute submissions from the very, very top teams. So we know this about the standings. Did UPC1 solve E? Maybe, maybe not. There is also EP Rouge with possibly 11 problems and ENS Ulm 1 with possibly 11 problems. Let's see the optimistic version of the standings. Here it is. Actually, we have somebody with possibly 12 problems. Mighty waiting for that big finish. Quite big penalty time, but should be enough to win if nobody else submitted everything. Then there are likely 5 teams that legitimately, oh maybe not, on the 6th place we have INSA, no time error with 11 problems. They didn't manage to submit J. Also huge time penalty. I might be wrong, but maybe we have here 4 teams who solved 11 problems, maybe incorrectly, but solved them at least partially, let's say. Then ETH Zürich teams with 10 problems each, optimistically. Let's get back to normal version, and then we'll go through the whole leaderboard. Before the freeze of the leaderboard, there were 7 teams with at least 7 problems. Here we have more than 20 with at least 7, 17 with at least 8. So that's quite some work during the last hour. And now the whole leaderboard. Regarding the balloons, it's different from competition to competition. Usually, especially for top teams, they will not get balloons in the last hour, to increase the suspension. Maybe still people in the bottom half of a leaderboard, they will get balloons just to get more and make it nicer visually and nicer for them. But you will not figure out the winner by counting the balloons. Yeah, come back in 90 minutes for the problem analysis session. Better one than my drawings with some professional slides. Then half an hour later, so 2 hours from now, there will be the closing ceremony and we will know the winners of SWERC 2020 and also who advances to the World Finals. Thank you all for watching and listening, and have a nice day. Bye bye.